Hello, my little chiglets. Today we are going to talk about section 3.3, and it is titled Dividing Polynomials. And within that, we do synthetic division. So, I know you've done that in Algebra 2. We're going to take it just a little bit farther. We're going to use our graphing calculators to help us out too. So, I'm going to review a few things. Let's try a quick example here. So we're going to take this polynomial and divide it by x plus 2. All right, so we're not going to do long division because that's just a pain. So we are going to just jump right into synthetic. So when you have it as x plus 2, in the press box is -2. Now the next thing you got to be careful of is that you have all the exponents accounted for. Well, I see x cubed. I don't see an x squared. I see an x to the 1, and the last 8 is an x to the 0. So I have to make sure I put a placeholder in. So x squared is not there, so we put a 0, then 6, and then 8. Then remember, we bring this one down, and then we multiply, then we add, then we multiply, then we add, then we multiply, and then we add one more time. Now this is the remainder. Now there's something called the remainder theorem. The remainder theorem says that this would be the answer. -44 is the answer if I were to substitute -2 into the equation. So the old-fashioned way is to put a -2 in wherever you see x in here, and you will get -44. So if I say use the remainder theorem, your answer is just -44. If I say put it in DQR form, what that stands for is divisor, quotient, and remainder. So what that will look like with this problem right here, my divisor is x plus 2. That's what I'm dividing by. So that's the D. The quotient is the answer when you divide. Now it's just not those numbers, you got to put the x's in there too. So I started out with x cubed, so when I divide it out to this x, it brings it back down to x squared. So this term right here, the 5, is x squared, then we just keep going. -10x to the 1 plus 26 with no x, and then the remainder we just write at the end. So this is the D, this is the Q, and this is the R. So the book doesn't say DQR, that is something that I made up all by myself, but it's a easy way to remember what form we're going to put it in. So you're either going to just say the remainder or you're going to put it in DQR form. Now, if, let's say we have the number 10, it factors 5 and 2, 10 and 1. They're called factors because they fit in evenly. Does x plus 2 fit in evenly to our original equation? Well, it's got a remainder. So if things have remainders, that means they don't fit in evenly. So we say x plus 2 is not a factor because it has a remainder. So if you ever come out to where you get 0 for the remainder, then you can say, yes, it is a factor. So let's try one and see what we can come up with. So I'm going to have 3 in the press box, and I have 2, -3, -11, and 6. So I'm going to bring down the 2, multiply, I get 6. Add, I get 3, multiply, I get 9. Add, I get -2, multiply, I get -6, and there we go. So it's a remainder. So what we can say is, now this was x minus 3, because it's opposite when you put it in the press box. X minus 3 is a factor of, now we have to think of this as our original polynomial. So it was 2x cubed minus 3x squared minus 11x plus 6. So you say yes, x minus 3 is a factor. Now what if I want to find the other factors? So 3 is we should say a 0. That's one of them, but there's two more, because if this is a power of 3, that means there are 3 zeros or 3 solutions. So what we do is we take this part, and we're going to call that the depressed polynomial. The depressed polynomial is depressed because we factored out one of its x's. So now it's not x cubed anymore, it's x squared. So the 2 becomes 2x squared plus 3x minus 2. And what we do, we set that equal to 0, and then we try to factor this side. All right, let's see what we can do. So I'm going to break this 2 into 2x and x. This 2, I'm going to just guess that it's 1 and 2. And let's see what happens. I get 4x and 1x. If I make the 4 positive and the 1 negative, I will get this positive 3. So positive 4 and a negative 1 gives you the 3. And then double check. Negative 1 times 2, is that negative 2? Yep, it all works. So I set those each equal to 0. 2x minus 1 equals 0. Bring the 1 over and divide by 2. So x is 1/2 is another 0. And then x plus 2 equals 0, bring that over and I get x equals negative 2. So I have my 3 zeros. I have 3, 1/2, and negative 2. So those are all my answers. If you forgot how to do this one, you do have the 4 blank method. You start out by putting 2x squared there and minus 2 there. You multiply those two, so 2x squared times 2 is 4x squared. 4's factors are 4 and 1 and 2 and 2. So you have to pick the one that will get you 3. So that would be the 4 and 1. So I'm going to put in 4x and 1x. And because it's positive 3, I need plus and minus. Then you take what these two have in common. Looks like 2x. Leaves me with x plus 2. These two have in common a negative 1. You always have to take something out, and you're left with x plus 2. Now, I know I did it right because these two match. So take those two out front, and then what's left, these two, become the other parentheses. And now we're back to what we had to begin with. So you can either guess and check like I did, or you can do the 4-spot method if that is easier for you to do. Okay, that is it for now. Ta-ta, and see you tomorrow.